Hi everyone, welcome to our webinar on future-proofing your Angular application. We're really excited to be holding this talk. My name is Nick van Weerdenburg. I'm the CEO of Rangle.io. I mistyped my name there. I was just doing the title slide last, so I apologize to myself for misspelling my name. And Yuri Takhteyev, and he's the CTO of Rangle.io, and he's responsible for our technical architecture practice. And So we're going to be talking about future-proofing your AngularJS applications, which is interesting as a subject because obviously everybody's quite interested in Angular 2 right now and what's coming down the pipe. And this is a challenge that all software platforms face, and it's top of mind. So we figured it would be good to share what we've heard from our clients and what we've done on our client projects and what we're thinking in terms of the long-term JavaScript client-based application sort of looks like. So technology, evolution, and durable code. A lot of people, they want the code they write today to last 10 years, forever basically. It's such a huge effort, it's a huge investment. But if we go back over history and we look at other frameworks and technologies, there's rapid evolution. So if we were to look at Java Enterprise Edition, Ruby on Rails, Python 3.0, ActionScript 3.0, these were all pretty traumatic in a lot of ways at different points. Basically, the future is always different from what's expected. So Rails did a great job moving with the changes, introducing a RESTful sort of things, more modular, embracing more of the ecosystem and being able to substitute in different pieces of the platform. J2EE was just a complete, massive, horrible failure that the open source community rose up and replaced it with their own solutions, which were pretty fantastic. And a lot of those ideas actually influence Angular today, such as dependency injection. Migrations are always challenging no matter what, because you change code and you're changing behavior of things that are running. No matter what your plans are, migration can always be challenging. What we have found that standards-based solutions work best. If you're writing a desktop application, you want to be cross-platform. You embrace ANSI and use that for a lot of your core business logic. Similarly, if you're building a JavaScript application, you can embrace plain JavaScript. And that was one of the big revolutions in the enterprise Java world, was plain old JavaScript objects, which most people are starting to think today is plain old JavaScript objects. And then the concept of a strong core and flexible edges. And Rails has always been a very good example of that, as has Java in the enterprise with all the modern frameworks. And that's where the core has the sort of the philosophy and the theory, and that holds everything together. But you can have lots of innovation based upon the needs of technology, the needs of the market, and where things are going. You can move from XML to JSON and adopt REST and those kind of things. But we do face a new challenge here. As more of our code runs in the browser, this becomes essential to think about this. Legacy server techniques don't work. And I put yet there because we're going to talk a little bit about that. But if you have a Rails 2 application, you can keep it running, and there are tons of them still running. And because going from Rails 2 to Rails 4 is a big jump, and it's a lot of rewriting going on, especially since Rails 1 and Rails 2 had really poor ideas of what a good Ruby web application architecture looked like. They suffered from a lot of the things that early Angular apps suffered, bloated controllers and not isolating business logic and not having very much modularity. That's evolved a lot. Rails 4 apps should evolve much better than Rails 1, 2, and 2 apps and Rails 3 apps, because there was a lot more thought into the architecture. And so those things apply to JavaScript just as well. So that brings up an interesting question. If you really want to sort of build for the future, are 3-year plans good or bad? Do you want to know what's going to happen in 3 years? Because if you were to take any of those technologies we talked about and did a 3-year plan at pretty much any point in their first 10 years, you probably would have had a heart attack, especially with J2EE. If you're looking at Rails 2 and someone shows you Rails 4, and as you go through the history, technology changes and it moves fast. And 3-year plans, from an architectural perspective and a migration perspective, are actually not a bad idea, but we're not used to them because most proprietary software companies don't release information like that because they don't want to scare people. And most open source projects, typically stick with their initial sort of focus and goal and they get replaced maybe in the future by new sort of technologies. But where technology change is extremely rapid, then technology platforms do have to adjust. And generally, I would say 3-year plans are a pretty good idea. So I'm very appreciative of what the Angular team is doing. But there's still, obviously technology is hard, and we have to think about it, because now that they have a 3-year plan, we need to have a 3-year plan. And I think that's what's causing the problem for most people. They need to have a 3-year plan, and they were just assuming the future wasn't going to change. So if you're doing anything that's enterprise, large, and complex that you expect to maintain over a long time, you have complex requirements, competing, conflicting requirements. It needs to be configurable, long-lived, and cross-system. These are a lot of challenges that you need to solve in web software. And there's one surefire future-proof solution, and a lot of people use this for a decade, and it was highly successful for maintaining the same code running at the same time. And I think this is actually a pretty cool solution. Standardize on IE6. So if you don't want to worry about the future and you don't want to have to upgrade your stack and your technology, IE6 is a great solution. I know a lot of banks that just actually moved off it this year in April of 2015. Not a very good user experience though, and probably not an option for most of us today. And IE6 was a little painful to work with, if you remember that. So we probably want to look for alternate solutions to that. So we want to have future-proofish architectures. I know we call this future-proofing your Angular application, and it might have been a little overstating the fact. I mean, you can future-proof anything if you stand still. That's the ultimate future-proofing. So adopt Angular 108, never change, or 1.3 and never change. And that can be fine, but if you want to continue to change and build your application, then you want to move with the times. And so what's a solid, pragmatic, cost-benefit approach to building an architecture that gives you the benefits of some future-proofishness and also the benefits of new features that are coming out? And does Angular pass this test, from an architectural perspective? Does it have that strong core and flexible edges, and is it future-proofish in its approach? So in NG Europe, the Angular team talked about the soul of Angular, and this applies to any version. And one is that it's dry, don't repeat yourself. And that's one of the things that really brought me to Angular initially. Another one was the structure that it gave to apps. That was another fantastic benefit. Anyone who'd lived through massive jQuery applications can definitely speak to that. And also seeing the rise of all these frameworks, that you can tell there was a huge pain in the JavaScript world because of the rise of Backbone and all these other frameworks and Angular. And then testability, which is an absolutely massive sort of benefit of Angular as well. So these 3 principles are actually pretty fundamental and pretty powerful in themselves. The features that they said that aren't really changing are dependency injection, data binding, directives, sorry, misspelling there. The router, the routers, like there's third-party routers. So, some of these things are at the edges, and you'll have a lot of flexibility there to use what you want regardless. Filters, animations, forms, expressions, protractor, karma, and mock. So that's a large sort of core of what delivers a lot of value with Angular. What's new? A mobile approach. There's an improved router. There's a big focus on performance and scale. But the big thing is ES6 and what that drives. And as well, what the Angular team has done, I think is best summed up, is coming up with an actual component model that's more pervasive across Angular. So instead of it being a web page development and extension language with a component model thrown in with directives, rather there's a overarching component model which will interact with web components in the future. So the big things that are really driving the bigger changes are the ES6 features and also the overarching component architecture, which I sort of see it as merging controllers and directives, and you're using a class and class methods to represent your controller. So it's not really that they're truly going away, but they're being sort of folded into this general concept of a component. So the current Angular 2.0 status, is this conjecture? Is this real? It's well validated. The team pointed out they've done a lot of prototyping. There's lots of new ideas that have been tested in Angular Dart. They've had very external design docs and discussions, and they've taken a lot of feedback. And some of the biggest areas that you should be afraid of with Angular today going into the future is scalability and large project support. This is something not a lot of people have done yet, and this is a benefit that's gained by moving to Angular 2 when it's out there, and it's something you can gain when you need to by basically, rather than having to invest a lot of money in scaling Angular 1.3, when you get to that size, you can look at moving on to some of the Angular 2 sort of features. So it's a lot to keep in your head. So we did an analysis of Angular 2 from a value risk matrix perspective and looked at some of the main things that are coming out. So dependency injection is still there, but it's changed. It's moving to ES6. It's going to have true dependency management. So once you've actually imported a module, it's not going to be available globally throughout the whole system, which is one of the dirty little secrets of Angular modules. And it's introducing a query concept. So rather than having explicit references to parent components, there's a query that you have like a panel that's going to look upwards to the nearest tab, and it's going to find that reference and communicate using that sort of search mechanism. So you have a dependency injection query mechanism that sort of gives you some structure that stops you from tightly coupling components. So it's actually a really cool feature. So, what is the value? So moving with ES6 and modules and true dependency management and that query model and that core component model, the value is extremely high, especially for large applications. The risk and the effort are both very low in my mind because this is a very declarative sort of part of Angular. You're declaring what your modules are and what the relationships are, and you can take any junior programmer, and that's my measure there. Can you have a junior programmer and have them migrate your Angular 1.3 code to Angular 2? And so that to me gets a resounding yes. That's quite easy. Modules, again, it's ES6, new syntax. You can declare the dependencies. There's a lot of overlap with the DI there. Very similar again, though. The value is massive. You don't want to be on a different module system. Imagine using mixed modules in Node. The risk is low and the effort's low. Again, any junior dev can do that. With directives, it's declarative again, but it's a lot more effort, I think, in terms of it's a declarative approach, and what you're doing is you're removing the directive definition object, and you're using classes and DI and the component model now to achieve it. So I think there's a straight translation in most cases between the two. So the risk is fairly low because also most people get stuck building more complex directives anyway. The effort is probably a medium effort because directives can be hard to unravel and figure out, and there's going to be 3 different types of directives. But for most projects, I think that the value is extremely high and the risk is fairly low. Scope, well, the current inherited scope model is actually pretty dangerous as it is, and I think most projects are moving to the controller as syntax in Angular 1.2 and 1.3. If you've built your application with a smart approach to scope and controllers, the value is very high. And moving to the new model, it's easier to understand, it's cleaner to read, the risk is low, the effort's medium. If you have crazy nested scopes with no concept of where data is coming from and really conflated sort of entangled logic, then well, that's the problem you have with your code base today, and it has absolutely nothing to do with Angular 2, and you should probably be fixing it regardless of what framework you're using in the future. Controllers are declarative as well. They're now going to be in components. Classes, they're not technically, they're technically going away, but in a sense they're not. It's really your evaluation context for your directives is now going to be classes and not something that's sort of arbitrary. So the value is very high. The migration effort is medium. The risk is medium because of the way most controllers have been written. If you write your controllers to be thin controllers with most of your logic and services, I would say both of those drop to fairly low. You could actually just wrap a lot of controllers in components, I think, from what the model of Angular 2 is looking like, and migrate a lot of the code that way. Again, because it's declarative, I think declarative changes are a lot easier to reason about, and they're a lot easier to implement if you have a clean, easy to read and reason about code base, and it's not going to require significant thinking to make the migration. But you can have massive amounts of code, and there can be complexity, and adding all this up together, it could be something that's extremely daunting. The last 2 points are messaging. So messaging is imperative. Messaging in Angular is actually pretty messy in terms of emit and broadcast and its dependence upon scope. The new model is easier. It's easier to reason about, but it's different using the dependency injection model. And router, the third-party router will be based upon a lot of the ideas in UI router. I'm sorry, the new router will be based upon a lot of the ideas in UI router, but you can also use third-party routers. And so the value there to me is medium, maybe low, and the risk and the effort are fairly low. So overall, there was nothing here that actually would scare me from moving to Angular 2 from a code base perspective, except for the overall effort. Architecturally, I think there's a lot of commonality there. I was going to add one more thing in terms of all of these different features, I think you can get a good sense of whether changing this is a good idea by what the level of innovation in the space is. And so if you go look at any large Angular project that's being done in a bank or a large company, they are using Require.js and other processes to solve these problems in terms of dependency management. And so if there are significant third-party approaches, either Require.js or Browserify, for modules and DI, then there's obviously a problem there, and you hope that there would be innovation and progress in the core. Directives, web components, and other ways of building components. Directives are hard to learn. There's issues there. There's not a lot of innovation because it's so tightly coupled with Angular, but that's one area that will have a huge boon to developers in simplifying that. Scope, the Angular team's already migrated to the controller as syntax and provided those features, so the pressure to innovate's there. Controllers are pretty straightforward, so I don't see that there's a lot there in terms of what's going on in, say, the Angular ecosystem right now. Messaging, a lot of people are looking at third-party message queues and different ways of handling it in Angular because of edge cases with scope-based broadcast and emit. And UI router already replaced a core feature in Angular for most projects. And so what you can see here is that where you have a lot of third-party innovation around the Angular ecosystem is the areas where there's a lot of room to add value and improve. And I think Angular 2's changes line up very well with where that sort of pressure has been in the Angular sort of community. So this is meant to be a very simple table just to give an overview of value versus risk versus effort around core areas, and help in sort of reasoning about what the impact of Angular 2 might be on a code base. But there's still a huge question. What about Angular 3.0 and other future innovations? Do you want to be sort of stuck in a monolithic application? Angular 1.3 and 1.2, you can see that innovation and using different pieces there's a lot of benefit. A lot of people like to use Browserify and they like to use different testing libraries. So what is really your architecture? And is your architecture Angular or is it bigger than that? What are the best practices for today? And what are the things you should be doing regardless of your time horizon? And with that, I'm going to hand it off to Yuri, and he's going to go into some of the broader approaches for today and for the future, and walk you through some really important architectural principles and sort of goals and potential approaches. So over to you, Yuri.
Hello. So we, first of all, I think the important thing, of course, to mention, as Nick said, that it's not just about Angular 2.0, right? For a lot of people, I think the announced Angular 2.0 announcement just have really brought to mind that they don't have a long-term plan, right? I mean, and with specifically transition to Angular 2.0, we hope that there is going to be a fairly straightforward path because the differences are not as big. But what about going further, right? And what if a couple of years from now, really, you want to move to something else? You want to move to next big thing, JS, right? So the challenge there is that there is approaches you can take, but they all have, many of those approaches bring quite a bit of cost, right? So you have to decide to some extent what's your time horizon and how much money and time you want to invest today in order to actually future-proof your applications. So I'm going to organize my part in terms of levels, in terms of there's a couple of things that a couple of levels of preparedness you could invest in depending on how long-term you want to think. So to start off, let's actually talk about best practices for today. Now, those are things that you really should be doing if you're building your Angular 1.x application today, regardless of what your time horizon is. I mean, if your time horizon goes into a few months from now, then you should be doing this because this will save you time right now. And then we'll talk a little bit about how this actually will make your migration to something else later easy. And then we'll talk later about somewhat more aggressive future-proofing. So one challenge that we have run into, and a lot of other people have run into with Angular, is that Angular's nested scopes, they often seem to people as a good idea at first because they make it really easy to whip out something fast, but they really don't scale. And the first thing with nested scopes is that you really have to realize that they're not going to cut it as your model. I mean, Angular is an MVC framework, but nested scopes aren't that M in it. I mean, they can serve as your view model, but you really need to put your model somewhere else because your model needs quite a bit more independence from your view layer. Scopes are just too entangled in it. they lead to entangled code, right? If you have different controllers that are communicating through scope, then the end result of that often is that your controllers end up making way, way too many assumptions about each other. It complicates testing. Now, Angular has done a pretty amazing work in making controllers fairly easy to test, given what they are, but it's still quite a bit more difficult to test than services. We'll talk in a second. And then finally, if you don't do nested scopes right and you use a lot of watches, you can actually also really suffer in terms of performance. So for all of those reasons, we've been advising everyone to use scopes quite sparingly. And instead, we've been basically repeating the following as a mantra, that code that can be written without referring to controller scope should be written this way, and it should be placed in a service. Services in Angular, on the other hand, provide a really simple solution for a lot of problems, and that is really where the bulk of your code should go. Services are really easy to reason about because you can actually understand the service independently of all of the, completely separately from the UI stuff, but also really you get a lot more independence from other services. They're really, really easy to test, much easier than controllers. And they really help you avoid entanglement in your code. You can make your services self-contained, in which oftentimes is a little harder to achieve when with controllers, because your controllers sort of by definition have to kind of span the some business logic concerns and some UI concerns. So the more business logic you bring into controllers, the more that business logic ends up being entangled with your view layer. So then finally, and this may be sort of not fully often appreciated, is the dependency injection model that Angular follows is really actually pretty damn good. A lot of people just use it, but they don't, without really thinking through the implication of it, but it's actually a really good system. And which is to say that as you move into some kind of post-Angular world, you may want to bring some elements of dependency injection just because it really makes a lot of sense. So consequently, we advise people to use services quite aggressively. Really, that's where most of your code should go. Now, obviously, you cannot build your Angular application entirely in services, so you do need to do your view layer. And on that front, what we've been advising people is two things. First of all, when you use controllers, make them skinny and use controller as. So avoid nested scope, give each controller an independent scope, have controllers communicate through services. So if you've got 3 controllers that really all need the same data, they should inject the same service and ask that service for the data. And then use fully isolated directives. I mean, the more isolated your directives are, the skinnier they are, the least work they do, the easier your life will be today and also in the future. Now, but you could ask, well, what does all of this have to do with Angular 2.0? And furthermore, what further with sort of whatever is the next big thing going to be? How will this help us the transition? Well, let's think about the effort of migrating from Angular 1.x. If you have written a lot of code that's really sort of written as entangled controllers seriously leveraging nested scopes, where most of your code is in your controllers, as you migrate even to 2.0, and especially if you migrate to a framework that's really very different, that code may well end up being a write-off. Though we'll talk a little bit about that later. Now, if you are doing sort of good controllers, your controllers are skinny, you're using controller as, you're using isolated directives, then that code you might be able to bring with you. Now, will depend on a couple of things. It will depend on how similar the next framework is going to be. So if you're bringing it to Angular 2.0, your life is going to be quite a bit easier than if you're bringing it to a framework that's radically incompatible. And it's going to depend on what kind of third-party or solutions or Angular solutions are going to be provided for migration. We can imagine potentially controllers being transferred in a fairly seamless way, but it remains to be seen, and it kind of depends on you actually transitioning to something that uses a fairly similar philosophy. So to 2.0 is probably going to be okay. To a different incompatible framework, we'll have to see. Now, when it comes to actually reusing your services, however, you can be fairly optimistic. I mean, you can be definitely fairly optimistic when planning a move to 2.0, but you could actually also be optimistic when moving to something potentially entirely different. Why? Well, because Angular services are really, at the end of the day, modules with dependency injection. And as a result, they're fairly easy to stub out in the sense that you could take your service code and remove Angular and write your own Angular-like code to really bring your services back to life, to just instantiate them and load them and then put them inside of an application that really doesn't have most of the Angular code, because dependency injection is actually fairly simple. It's a great idea, but it's fairly simple in terms of implementation. It's not a lot of code. And so what you can then do is you can use Angular services without Angular 1.x, or for that matter, without Angular altogether. So you can bring your services to whatever the next big thing is going to be. Now, the catch is that you will need to provide dependencies. So I mean, if your service, let's say, just makes use of $Q and $HTTP, then you will potentially need to provide an alternative implementation for those, which is actually fairly straightforward. If your services try to make use of absolutely every single injectable service that Angular provides, then you may actually have a bit of a harder time. Though we would sort of expect that there will be third-party libraries that really do this for you, that provide those mock implementations, helping you move to a different framework. So we want to now show an example of what we've been playing with. Now, it's a bit of a proof of concept. It's a simple library. It's a really simple library. I mean, it's really, all of it is about 50 to 100 lines of code for the most basic part, that allows you to stub out Angular code, to basically remove Angular and give you an option to just supply the dependencies by other means and use your services without Angular. And the nice thing is that you actually still get the full benefit of dependency injection, because really just using the same module, the same model. So this is the URL if you want to go and check it out. It's not a lot of code there. As I said, it's about 50 lines of code. And we'll show you some examples of how you would actually use this to use your services without Angular. Again, treat it as a proof of concept. We're going to be probably investing more effort into this and make it a little bit more robust, in particular in terms of providing some of the most common dependencies. But you could also think of this as your insurance policy, in the sense that this is a proof of concept that shows that the effort you invest in your services is not going to be lost. You can actually carry it over to other things later. So here's how you convert a service using Nebula. You add one line. As you can see, the last 3 lines of that example are actually exact service as it was. And what we do here is that in this example, we're using CommonJS style module. So we're converting our service into a CommonJS module. And we are going to require Nebula. We're going to require it under the name Angular. And this is going to take the place of our Angular global. So this code is now going to run in a context where there is no Angular global. And instead, Nebula provides the .module method, which gives you an object that gives you .factory. Right? So this code can now be loaded, and which registers your service, and your next step becomes to actually load it. And the step for that is actually really simple. Again, we're using here CommonJS, but this can all be done with require.js. I mean, in practice with Angular, require.js doesn't offer you that much of a benefit over CommonJS, so we're just using this here for simplicity. So again, we're going to require that service that I just showed you. We are on the second line requiring Nebula. We instantiate the service, and then we get a copy of it, and when we make calls to it, and that's it. So there's no Angular in the picture at all. Now, of course, this works because our service is actually so simple that it has no dependencies. So there's a catch in that sense. If your service requires dependencies, you will need to actually provide them. If your service requires dependencies that have been converted the same method that I just showed, then Nebula will actually load them for you. But if you want services that used to come from Angular, you will need to do something about it. So here's the really simple example, which we've actually ourselves used quite a bit in testing, is you use actual Q implementation as an alternative to $Q. And this works for pretty much all of your code. And once you do this, now $Q becomes injectable in your code. And if your services are only using $Q, you are set. Of course, with other libraries, you may actually potentially be looking at a bit more work, right? So implementing $timeout, $interval, $HTTP will be a little bit extra work, but it's actually, as you can imagine, entirely doable. And when you think about the cost of migration later, that effort is really not that scary. Now, so this is kind of level one. So those are best practices that you probably should be engaging in, and those best practices give you a good, will give you a lot of more confidence that your code will not be entirely sort of write off if you decide to switch to some other framework. But if you are thinking further ahead, you really may want to actually invest in more modularity. Now, more modularity will make your life simpler in the future, and it also actually has quite a bit of potentially architectural benefits today. So how do we do this? Well, one thing to do is to consider using plain JavaScript. Not all of your code needs to be implemented using Angular services. What you could do is you could just write your code today as plain JavaScript modules, and then you export them as AngularJS services. So some frameworks have taken this approach to some extent. For instance, Ionic has done this, where a lot of their code is actually written as plain JavaScript modules, and then they go ahead and actually expose those services to you as Angular, or they write AngularJS services that leverage plain JavaScript modules. Now, there's a small catch with this approach. And then what you can also do is you could go ahead and inject AngularJS dependencies as needed, right? So if you could write in Angular a plain JavaScript module which expects let's say if you want your module to still be using $Q, then $HTTP, then you could provide it with $HTTP, and it will have it use that to make HTTP calls. Now, the catch with that is that you might just find yourself reinventing Angular's DI. This is the approach. I mean, when we've played with it, we've just found ourselves gravitating back towards Angular DI in the sense of we've tried alternative approaches, but really at the end of the day, Angular's dependency injection model really makes a lot of sense, and you will find yourself perhaps just doing the same thing. So a solution becomes then is, well, maybe actually embrace it. And so use a system somewhat like Nebula, what I just showed you, where you can actually fake Angular to basically take just the DI component of it and use it inside of your modules, isolating your modules from Angular in a way where they just expect certain dependencies to be provided with them, but they don't make assumptions about whether those dependencies are coming from Angular from somewhere else. So we have this approach, we call it wrapped services. And it also resolves another big problem with Angular services, that Angular services, there's no way to have private services today. All of the services you create, everyone can use it, which of course invites your users to make use of services that may not have necessarily been intended for public consumption. So with this approach, we build a package of Nebula services. So I mean, again, Nebula services are basically Angular services, but they've been we are going to run them. They're going to be the kind of Angular service that we can actually load without Angular using our mocked out dependency injection approach. We will then inject actual Angular dependencies, and we'll re-export the whole chunk of functionality as a single high-level Angular service. So our Angular service will then basically hide from outside all of the little baby services that are private to the 3-layer implementation details. And then the cool thing is that we enjoy more isolation with this. So we give someone a service, and we can be assured that they're not going to actually sort of call the implementation services, and we can then go and build a whole bunch of really small services and not really worry at the end of the day that we are going to expose them. And we now have a solution that we could use with or without Angular 1.x. So let me show you sort of a quick example of how we would do this, and it's fairly similar to the example that we showed you before, where what we do now is we require, and we've done this change recently to one of our own libraries on a sort of experimental basis, which used to have a dozen of smaller services that would, because we really want to keep our services small, right? But we really, at the end of the day, also want to expose them to the user as a single service. So in this case, we will require a package which will require all of the individual services which have been converted to Nebula. We will then define a new Angular module. We'll define within it a single service. This service will collect a bunch of dependencies. It will put those dependencies into Nebula, which is our Angular sort of replacement, and instantiate a service from inside Nebula and return it. And so now what we achieve with that is we still write our code just as any other Angular services, but we first of all export it as a single service, and second, we've got a really clear identification of what are all the Angular dependencies we're using. So we know that our code now uses those 7 dependencies and 6 Angular dependencies and underscore and nothing else. So that gives us a bit of assurance in the sense that we can now know what's going to be the scale of work that we're going to have to do if we decide to actually migrate this to a framework other than Angular. And with a little bit of effort, we can actually go ahead and now offer this package as a non-Angular package. Now, this approach, so I think this approach ends up being kind of good if you want to think in terms of mid-range horizons, and if you want to think of projects that are large but not really humongous. With really, really large projects, you have to, it doesn't end up being enough to have a plan on how you migrate your code. How you're going to take your Angular 1.2 code and convert to 2.0 or to convert it to whatever else you're going to want to use at that point. You have to think of it, how are you going to actually convert it piecemeal? Because I mean, if you've got 300,000 lines of code, you don't want to sign up to convert all of this code to Angular 2.0 just because there's one component, there's one part of it that really would benefit from those new features. Because I mean, if most of your code works just fine in Angular 1.2, I mean, like if it ain't broken, don't fix it, right? So what this means, however, is that you need a plan for how can you actually build your application in such a way that it can actually combine multiple frameworks in it, where there's part of the framework that part of the application that uses Angular 1.2 and part of the application uses Angular 2.0. Part of it is using the whatever is the new and exciting thing that has come up. Now, we've thought a bit about this, and so the kind of isolation you want, right, is you want, and so true isolation really means two things, right? It means encapsulation, which means that you can build your components in such a way that whoever uses them really cannot peek inside and really cannot sort of go ahead and use features that they really should not be using. And it also means confinement. I mean, confinement means that your components can't go ahead and reach out and, for instance, start making use of your globals, right? Because once your components are making use of your globals, then it means if you're using frameworks that actually impose conflicting globals, you really have problems. And we've looked, for instance, into solutions of whether we can actually make 2 versions of Angular run within the same context and not sort of stomp on each other. But we eventually concluded that this is a uphill battle because, well, you can plan on getting that. Maybe we can get Angular to do that. But I mean, what about every other library? I mean, it really takes, in this case, one library that has made an appropriate use of globals to just for the whole thing to stop working. So really, we want proper encapsulation. We want our components to not see the globals in the larger scope, and we want our sort of parent scopes to not be able to reach inside the controls. The solution that we've are mostly thinking about now, and I will demo this in a second, is based around sandboxed iframes. Now, I mean, and web workers. So I mean, iframes for things that really need to have a UI component, and web workers for things that do not, for services that really plain data services. Now, I mean, suggesting iframes may sort of be a little bit controversial because I mean it's seemingly like it's like an ancient technology that people have avoided for good reasons. But ultimately, after thinking quite a bit about it, we feel that this may end up being your best solution because that's one way where you really get true isolation. So in this case, you have parts of your application actually have different JavaScript context. They cannot see each other's data at all, and they communicate instead via post message. Now, this approach is actually, I mean, not entirely new. People have been using this quite a bit with third-party components, right? I mean, when you embed Google Maps, that comes in an iframe. If you ads have been doing this for ages, right? Because you really don't want your ads to be going and modifying your page, right? And the ad also kind of doesn't really know in what context it's going to show up, so it really wants some isolation. But this can actually be quite useful for a large-scale application where you can really say, we're going to break our application into some parts, and those parts are going to be completely independent. We're going to treat them as if they were third-party components, which means that the teams working on different parts can go somewhat different ways. They can be developing on different sort of schedules, and we could convert individual components to different frameworks without really committing to converting everything at the same time. Now, the downside to this approach is that it requires a little bit of plumbing. I mean, a lot of people have shied away from iframes because there's overhead. Now, this overhead is may, first of all, well be worth it for some projects because what you get in return is you get longer-term maintainability. You get the option of upgrading some of your components without upgrading the others. And then the second thing is that we're hoping that with a bit of more of a third-party libraries, we can actually get some of the plumbing kind of taken care of and where it wouldn't be quite so daunting. So let me show a quick demo that we've built of basically a multi-framework application. I mean, it's a very simple application, but the idea is that it's an application in which different parts are running in separate frameworks. So in this case, we've got to start with, we've got two applications. So we've got two components which are both implemented using plain jQuery. They don't see Angular. They don't know anything about Angular. And then we've got an Angular 1.2 component. They're all basically very similar, but they're implemented separately. Right? They're really independent components. And then finally, we've got an Angular 1.3 component that and so what we could do here is we can actually send messages between them. This is using post message. So we could say hi. There's no delay, as you can see with that. Now, there's some styling issues that we've been sort of running some challenges. We're still working on this, but we did actually get to a point where this is actually resizable, right? So we can resize it. It actually is responsive. If we actually go do it further, as you can see, it now changes to, switches over. So this is an example. And so in this case, we are just sending up. We have communication between two jQuery components. Now let's do the same thing with our Angular 1.2. And so those are incompatible applications. They're services that can't live in the same shared scope, but they communicate fine over post messages. And then the idea is that so we can now go ahead and create new ones where we can just specify what component we want. And we could say where we edit. And now we kind of got communication between them. So I mean, it's a fairly simple demo, and there's still corners that we are looking to resolve, corner issues that we're looking to resolve. But we feel that this approach can actually provide at least the first stab at a larger scaling of applications, right? Where we can now see that framework continuing for quite a while because individual components can just stay as they are. and we don't really, in this case, when Angular 2.0 is concerned comes up, we're going to build our next application, our next widget in Angular 2.0, but we are not going to convert this. And this is what I said earlier, that can you reuse your controller as well? Maybe, in the sense that if you've got those messy controllers, but they are isolated this way, then you can actually still reuse them. You just need to isolate them, and you just need to continue using Angular 1.2 with them. So this is the URL where you can find the demo. Again, it's a fairly straightforward demo, but we're sort of looking forward to expanding it and kind of finding, using it essentially as an experimental framework to build a few more sophisticated things and actually see how things work in practice. So another thing that's worth mentioning with this approach is that it allows us to actually create proxy interfaces for our components. What I mean here is that with this approach, we could take and build an Angular, say 1.2 component, we could iframe it, and then we could represent it as a directive in the parent context. So which could then take care of all of the plumbing, where we basically just have the directive piece already knows how to communicate through the change of context, where all you really need to do in your parent context in serving the user application is you add a small script that defines just the proxy directive, and then you start using your directive. Now, in that case, when you later switch to something else, let's say you switch to web components, you will only need to re-implement this proxy, right? So your underlying, whatever sits inside of the iframe could still stay the same, but what happens inside, but what appears in your parent context, you will provide a web component sort of wrapper for it. And of course, in the same way, what we could do is we could provide an Angular directive representation of what really is, at the end of the day, a jQuery component, not because we love jQuery, but because we just happen to have actually built a fairly massive chunk of functionality in jQuery. So now, speaking of web components, I mean, a question that naturally comes up is why don't we just use web components? Well, the answer is that web components do help us with encapsulation somewhat, but they really do. I mean, so Shadow DOM in particular does that. It doesn't really isolate it to quite the same extent. I mean, you still end up having JavaScript that shares global context, and so consequently, sort of combining multiple incompatible frameworks becomes difficult. Now, and in fact, even if the web component specification recommends that if you want true isolation, you will need to kind of go the iframes or web workers route. No, that said, I mean, this is not to say that web components aren't great. They may really be very useful first as a way of providing an alternative wrapper, an alternative proxy representation for things that are kind of bundled inside iframes, or for smaller units. So now, and then finally, to close this, I think a question that everyone kind of need to ask themselves is, what's your time horizon? I mean, are you building an MVP that needs to be done in 2 months, and really, if you don't get it done in 2 months, it kind of doesn't really matter what happens in 2015, because you're not going to be alive in 2015, or your company is not going to be? Or are you building something that really it must last? And depending on how long-term your requirements are, based on that, you may want to invest, either go for quick and dirty solutions. So, I mean, we recommend still sticking with what we've outlined as current best practices, but maybe skipping on the more sort of heavy-duty future-proofing. But if you really are concerned about the future, then some of those things may well be worth an investment. Thank you.
Thanks, everyone. Thank you for attending the webinar. We're going to answer some questions in a couple of minutes. Right now, we're going to do 2 final polls, and we'll start going through some of the questions while the polls are up. So one of the questions is, does the dependency injection query stuff seek to be a core solution to the problem that Require.js and Browserify are currently addressing? And for that, no, not exactly. The dependency injection query stuff is really about how you have different components work together across a page. So right now you have some really awkward parent calls, or you have a lot of broadcast and emit stuff going on the scope chain. What the DI allows you to do is actually find parent components by looking up the tree of your DOM. And so that it's a pattern that you're looking at, like a chain of command pattern, and it's not a tight coupling. And so that's where the DI query stuff comes into play. The ES6 modules will address some of the required JS and Browserify sort of items. And the DI, the new DI, does solve some of the explicit mention of dependencies, so you don't have namespace collisions, and you do have a better traceability of dependencies. So in that, I guess, respect, it does solve some of those problems, but it doesn't address the, say, the asynchronous loading concepts. Someone mentioned it would be interesting to take an AngularJS to do and refactor it to basically future-proof it. That's a great idea. In another webinar, maybe we'll go through an in-depth sort of architectural example. Someone says in one of the examples, you're grouping a bunch of services into one larger service. Isn't that essentially combining all your dependencies into one large one? That seems naughty, since you would be giving services to components that don't or possibly shouldn't need them.
Yeah, so on that one, actually, I don't think so, because what we do, of course, is we don't, the idea that is not to take all of the services and basically take all of their functionality and expose it as one large service, right? But the idea is that we build, so in this case, this is, we've been doing this with Coast, which is our sort of framework that takes care of a lot of server-side interaction, and it has a lot of plumbing underneath that the user of Coast doesn't really need to see. So now we implemented this originally as a bunch of small services. Now we implemented small services because we wanted modularity, but what we ended up with was a whole lot of services that the user really should not ever be using. Now we've tried we've prefixed them with underscore just to make sure that they know that they're not shouldn't be using them, but that's really a kind of very suboptimal solution. So in this case, what we do is we now have our kind of umbrella service, which really exposes only the high-level functionality, only the things that the users actually should be accessing, and gives us the freedom then to really go ahead and change the internal implementation and drop some of those services that we use underneath, or maybe switch to a non-Angular solution. And meanwhile, the contract that we are having with the user is just the one service that we're providing them with, which actually has a fairly limited set of high-level functionality.
All right. A couple more poll questions and a couple more questions from the audience, and we'll wrap up. So
I see a question about the multi-frame app demo that is on GitHub, as is Nebula. So if you go and look at our account, Rangle, so github.com/Rangle, you will see both of them. But I mean, otherwise it's GitHub, it's Rangle/Nebula and Rangle/multi-app, multi-framework app.
all right, another one here. @script seems to me like yet another attempt to replace JavaScript. How many times is Google going to try this? GWT, Dart, etc. So I think that @script is not so comprehensive in that, maybe they have given up, and there's a couple of things that they would like to use, and that's types and annotations. And that does help with some aspects of development workflow and tooling. So I find @script to be a happy medium, largely, in that it's based upon ES6, and it's not really sort of there to really replace JavaScript. I hope that that's the case and that it doesn't go down a crazy direction, but it seems like it's a fairly light extension, and they are committed to letting JavaScript still do.
And so there's a fairly reasonable chance, I would say, that this ends up in something like JavaScript 7, I mean ECMAScript 7. And it's the delta from ECMAScript 6 is really not that much. I mean, if you compare @script with ES5, then it seems completely different. But compared to ES6, it's really just adding two small, very specifically targeted things, and where the compilation step actually changes your code quite a bit. Now, I think that Google is also probably betting, the Angular team is probably making a bet here that you're going to be already making a transition to ES6 that's going to be disruptive. You're going to be transpiling your code probably for a while. So in a way, it may be another attempt to replace JavaScript, but even if so, it's a very well-timed attempt in the sense that when you're going to be switching from ES5 to ES6 is going to be probably the time when you actually could consider something like that. But the delta with ES6 is really not that much.
All right. Next question. What is up with the poll questions? They're distracting. So I apologize for that. I was inserting them when I thought it was not too distracting, but we'll work on maybe making them a little more seamless and pausing for them. We wanted to run the polls to be able to give some feedback from the audience because we have quite a few people on the talk, so that hopefully the feedback you got from the poll questions made it worth the distraction. How do you see Polymer working with Angular 2.0? Will there be much overlap, or will they go hand in hand? And so one of the goals with the syntax for the templates in Angular 2 was to work interoperably with web components by focusing on properties. And it's hard to say, though, because I think there's a lot of engineering challenges there still, and Polymer is still pretty early, but that is their goal of the Angular team, is to work well with standards and Polymer. So largely, Polymer is a shim that would get replaced by web components down the road, and Angular wants to work well with web components. So I would say that the answer to that would be that they would work hand in hand fairly well. And then the question, can you post the source of the post message demo? We hadn't really thought about that, but we'll look into that.
Oh, it's on GitHub.
Oh, it's on GitHub.
Yeah, it's on GitHub.
Okay, so that's already on GitHub. So there you go. Is the multi-frame app demo on GitHub? So same question. I guess the answer is yes to that. Angular 2 is dropping support for IE9. Can you suggest any possible measures to mitigate that? That's a very good question. I'm a little sort of struggling with that a bit, though I think IE9 is going to go away fairly quickly. It doesn't have any kind of anchor, and the market as a whole is moving to like evergreen browsers. That might be something that will change down the road. I know that a lot of like large financial institutions are using Angular, a lot of enterprises. It's a very data-driven framework that has wide applicability. I've called it the power builder of the web, for rapidly consuming REST APIs. That's going to be interesting from an IE9 perspective. I'm sort of largely expecting that it's probably going to go away by itself, and there'll be the ecosystem will support and find workarounds for IE9 to make things work, which is typically what you do with Internet Explorer browsers anyway.
So for, let me actually answer the question. There's a question for multi-framework app. Does it mean there is a copy of Angular on each iframe that use Angular? Initially, yes. And I mean, this is a sort of decision not to necessarily be taken lightly, but it's not the, I don't think it needs to be a deal breaker. So there's two, and there are two reasons for this. First of all, I mean, if you are going to be actually, and if you're going to end up with an application that really where a component is using 1.2.1, you have got another component using 1.2.2, and you've got another component using 1.3, and you've got a third component using 2.0, then the fact that they each have their own copy of Angular is going to be a blessing, right? So that's one thing. Now, and also in the longer term, I don't think it's going to be a cost in the sense that the weight of old Angular in your future browser is not going to be necessarily that much. Now, in the short term, this does present somewhat of a cost, and I think there are ways to mitigate that, where basically essentially through injection. So where we basically say we don't want the child context to go ahead and just grab whatever they want from the parent context, but we may want to look for ways to provide it them with some of the facilities. So we're looking at some of the solutions, both either in terms of proxying functionality or in terms of at least, I think the bigger cost there would not be so much having multiple copies of Angular in memory. I don't think this is going to really be a big deal, but from having fetching Angular multiple times, and there we can sort of imagine a few different caching solutions. But that's a direction that we are thinking quite a bit about, and we're hoping to have better solutions for that. Again, this is a proof of concept at this point.
Someone asked, how can I make my Angular 2 app work in IE6? I have to hope that that was actually a joke, because you're not going to get any luck there. That would be going too far back.
Well, Java applets.
Yes.
A Java applet that actually can run more than HTML5
Right.
and ES6. That's
so. And then actually, what you could end up with is having a emulation of IE6 in JavaScript at some point, because everything's been implemented in JavaScript to date. There was a good question. There was a lot of emphasis on using iframes as part of the solution. Was that move backwards meant just as a kind of stopgap, or was that a seriously suggested solution? Couldn't tell. So that's a really good question. It really depends on the context of what's going on in your application architecture. We've seen quite a few clients using iframes for a wide variety of reasons. And if you say had a massive piece of code that was written in Angular 1.3 and you wanted to move to Angular 2, but your time frame wouldn't allow for it, from an economics perspective of getting to market, then you could take some key Angular 1.3 components and directives and use iframes to bring them into your upgraded application. There's a few other approaches as well. Yuri, you want to comment?
I mean, it is meant to be as a serious solution and not necessarily stopgap. I mean, obviously, stopgap until we've got an alternative solution, which is not really even on the horizon, because I don't think web components really do everything we want them to do there. But at the same time, I think we need to think of what exactly is. I mean, and we ourselves, it's a solution that's not like kind of coming lightly. But I think the big reason that people have been avoiding to use iframes, and the reason that we have not, the reason a lot of people are excited about web components is that they're a little too heavy. There's a little bit too much work that you need to expend on plumbing. So what our hope is that some of those iframe solutions could actually be made easier if plumbing is taken care of. So for instance, in this case, what we have is we've got a bunch of components that are actually reusing the same library that provides a higher level wrapper over post message, right? Because if you're down to just doing post message yourself, it may seem really daunting. Now, the second thing to consider is that when I say when we're talking about iframes, definitely not suggesting that you should implement your application as a combination of 200 different iframes, right? You need to chunk your functionality in fairly large chunks that really make sense. And in that case, the fact that you've got to communicate through a really thin interface such as a post message may well actually start seeming like a blessing, right? Is that it seems like, if you really kind of think of this as like whatever is now a directive in your code is going to now be an iframe, that'll be insane. And the amount of extra work you will need to be doing is going to be, there's going to be massive overhead, and you're going to actually be doing tons of extra work. But if you're thinking, for instance, let's say that you are building an application where there is a sort of a single sign-on component where across a bunch of your enterprise application, there is a component that takes care of sign-on, and then there's a component where the user manages their account. Implementing those things is, iframes, where we're talking about the large chunk of functionality, I think actually may well end up being the solution, yeah.
All right, so we've got about 6 minutes past. I think we got through most of the messages, most of the questions. If you have any other questions that we didn't get to, please send us an email. That information is on the slides, and we'll send an email around with the recording and the slides when they're available, probably later this week or early next week. So thanks again, everyone, for joining us on this webinar. I hope you found it useful, and hopefully you come to our next one. Thanks.
Thanks.